Welcome to this video on exponents. As usual, we're going to talk about the vocabulary of exponents. What are the parts? Why are they good? What can we use them for? And then we'll go through some how to do them and maybe some tricks, some problems you may run into along the way, how to solve them. So let's just jump right in. This is an exponent, 3, and then this little number up here is the exponent. So 3 squared. So the base would be the 3. The exponent would be 2. Now when it's 2, we call it squared. When it's 3, we call it cubed. So we could say 3 squared in this case. If it was a 3 to the 3rd power, we could also say 3 cubed. Now 3 to the 4th power, to the 5th power, to the 6th power, we just say to the 6th power. But to the 2nd and 3rd power, those do have special names. They're squared and they're cubed. So what is an exponent? What does it represent? Why do we care? Well, let's take that 3 squared. What that equals is 3 times 3, which equals 9. So how does this work? 3 is the base, which is these 3's. 2 means how many times we're multiplying it. In this case, twice. So if I said 3 cubed, 3 to the 3rd power, we would go 3 times 3 times 3. 1, 2, 3, the 3rd power. If I said 3 to the 4th power, 3 times 3 times 3 times 3. We would do it 4 times. So that's what an exponent represents. It's just, we could either write, like in this case, 3 to the 4th power, we could write 3 times 3 times 3 times 3, or it's quicker just to write 3 to the 4th power so that we know it's 3 times 3 times 3 times 3. So that is what an exponent basically represents. And here's how this is basically segueing in onto how we solve them. We just expand them out. So in the case of 3 to the 4th power, I could take this. 3 times 3 is 9. I could drop down the 3 times 3 because I didn't change that stuff, right? Well, 9 times 3, what's that? 27? And just drop down this other 3. Let's see, I'm going to grab my calculator here. 27 times 3, that's 81. So 3 to the 4th power is actually 81. So that is what the exponents represent. Now here's some problems you may run into, some trick questions that you'll probably see along the way. Let's say I have negative 3 to the 3rd power. Okay, now that would be, let's just take this part right here. 3 times 3 times 3, we remember, was 27. Then we just throw that negative out front. Now I did that a little quick on purpose. What this 3, this exponent is only going to this 3, and then we apply the negative. Now if we saw negative 3 to the 3rd power, this 3rd power is touching, actually it would still be negative 27. Let's go with a square. Let's try negative 3 squared. So that's negative 3 times negative 3. I'm sorry, this is 3 times 3, which is 9, and then we apply the negative. Now the other way you might see it is like this. This is different than this. Because this 2 is touching the parenthesis, it goes to everything in the parentheses, which includes the negative. So negative 3 times negative 3 is positive 9. And if you don't know how the negatives multiplication works, you can just click right over here. That'll take you to it. But in this top case, the 2 is only touching the 3. It's not touching the negative. So we square the 3, or we take it to the 2nd power, which is 9, and then the negative of what that is, so negative 9. So that's how we get it. So we could also see something like this, 2 plus 3 squared. Well, if we remember PEMDAS, our order of operations, you can click here. We'll link that right there if you forget the order of operations. So we do parentheses, then exponents. So what's in the parentheses? 2 plus 3 is 5, and then that square comes in, or that to the second power. So this second power is touching everything in the exponent, which is 5. So 5 times 5 is 25. So this would equal 25, right? So here's the different ways that you'll see it. You'll see negative 3 squared, or you'll see a negative base to an exponent, and the exponent's only touching this. It's not touching the negative. If we wanted it to touch the negative, we would put it in parentheses like this. Now this would be negative 3 times negative 3. This is just 3 times 3 with a negative out front. And then here is the other way we might see it. We solve what's in the middle, and then we bring it to the exponent. So 2 plus 3 is 5. So 5 to the second power is 25. So these are some of the tricks you'll see, but the basics of exponents is the exponent is how many times we multiply the base. So in this case, 3 times 3 times 3, because it's to the third power. And in this case, 3 times 3 times 3 times 3. We do it 4 times. It's to the fourth power. And just remember, there's your base. There's your exponent. And the big trick that you're going to see is you'll see it like this, and you'll see it like this. These are two different things. So remember, whatever the exponent touches is the only thing that the exponent applies to. Alright, so that's about it with exponents. If you like this video, please feel free to subscribe, and we'll see you next time.